Hello, everyone, and welcome to our engineer interview with Titi Oliyide. My name is Ollie, and I'm your host for today. Before we start, I want to say thank you for signing up to this year's competition. For those of you who don't know, this is the Leaders Award competition, where we ask the question, if you were an engineer, what would you do? Pupils from the age of 3 to 19 anywhere in the UK can join, and every person who takes part will receive a named and graded certificate from a real-life engineer, just like the ones we interview. The deadline for submissions is March the 22nd this year, so make sure once you've finished the competition in class that you send them on to us. During these interviews, we're going to be speaking with engineers who work on loads of different projects, all of them showing the wonderful, interesting and exciting things that happen when you work in engineering. Our special guest is going to start with a presentation about her engineering journey, and then we'll open up to the audience for questions. So get preparing those and pop them in the chat box, and I'll read them out in a little bit. But for now, I'm going to hand you over to Titi Oliyide for her presentation. Take it away.
Right. Thank you, Ollie, and hello to everyone on the call today. I'm so happy to be here. Okay, so as Ollie has kindly introduced me, my name is Titi Oliyide, and I'm a senior process safety engineer, as well as the winner of the 2023 IET Young Woman Engineer of the Year Award. So my career journey. So if I just go through my career journey with you. So I studied chemical engineering in Nigeria. And then I moved to the UK for a master's degree in chemical engineering as well. And since then, since graduation, I've worked as a safety engineer for oil and gas, the rail industry, and currently working in the green hydrogen industry as well. So what a safety engineer does basically is to make sure that the engineering solutions that we provide safe and sustainable. So we look at the designs, make sure that we can understand what could go wrong, and if things do go wrong, like what could then happen, and then putting the right measures in place to make sure that it actually doesn't go wrong. So in simple terms, that's sort of what we do. We work with other engineers and other people within the engineering industry to make sure that whatever we've designed and are operating is done in a safe way. So here you can see one of my in one of the projects I've worked on, which was an oil and gas facility. And with that, we're looking through how the plant works, making sure that we can understand what could go wrong if maybe a valve fails or we have an instrument not working properly, what could then go wrong, and making sure that we had the right things in place to mitigate that. I've also worked in, as I mentioned before, I also worked in the rail industry, and what that means is that the infrastructure or the equipment that is used to make sure that trains run smoothly from one point to the other, it's a very complex system. And as a safety engineer, I make sure that when I was working on those projects, I made sure that those worked together in a safe way, and whatever additional equipment we needed to make sure that that works well is put in place. So that's just a bit about my career journey. And I would like to also talk to you about the energy industry, which is where I currently work. So energy is very important for the life that we live right now. So depending on, in fact, from when we wake up to when we go to bed, we are interacting with some form of energy or the other. And so, it really is something that we need to make sure that we get it in the right way, and in a safe way as well. We need clean energy to help reduce the effects of climate change, and that's why even for things like flying or making sure that we have the right kind of clean energy for industrial processes such as steel production as well, we need to make sure that we have those clean energy sources to be able to reduce the effects of climate change and reduce the amount of carbon that we emit as well. So there's lots of new sources of energy that we're looking at. So one of them is hydrogen, which is produced basically when you pass an electric current through water. You can then get hydrogen and oxygen produced, and so we need to make sure that these sources of energy that we're looking at are developed in a safe and sustainable manner. So if we can get these new sources of energy and reuse them to replace the current sources of energy that we have that are carbon emit some carbon, some CO2 rather, we can then use that to reduce the effects of climate change. So that's kind of what engineers get to get, some of the things that engineers get to do in the energy industry. Now, what do safety engineers do? So safety engineers are involved in, as I mentioned before, some of the things I've worked on in projects that I've worked on in my career so far. But I would just like to give a bit of a background or a bit of a overview of what safety engineers can do. So safety engineers work in every aspect of an engineering life cycle. That's generally the life cycle or the duration of a project. So even when we think about, okay, how can we solve an issue? So at the concept stage, we're looking at what can be the solution to this current challenge that we are facing. And engineers get together and put together what's called a conceptual design. So they kind of have an idea of how the solution to the challenge they're looking for might work. Then some research and development goes into it because you need to put together some details into that concept. So concept is a bit of a high level idea. And then with the research and development, you get into the details of that. Then you get into design development, whereby you actually start to produce a design saying, okay, for example, I want to get some hydrogen and I want to get that, using water. So you then identify that you want to go through an electrolysis process, for example. So that's the design development stage. And then from there, you go into the detailed engineering design where you start to look at the actual equipment that you need, the sizes of those equipments and how they'll work together as a system. Then you go into the procurement, the construction, and the commissioning, which is basically where you buy the equipment that you've designed, you construct them together, and you commission it. That's making sure that they are in a fit position to go into operations. And then when you do go into operations, that means you start operating your plant, and that means you're putting in your raw materials and you're able to get your finished product out of it, for example, your clean source of energy. Now that plant, as it's going on, you might have it on for say 20 to 25 years, and at each stage, you wouldn't run it continuously for that long, but you'd want to sort of maintain it. That means you're sort of taking it down, looking into it, looking into the equipment, and making sure that they're still working well and they're still in a good state, or in a good state, basically. At different points in time within those 20 years, you might need to change some things, and how you manage that change is also very important. You might need to upgrade some equipment because maybe some equipment gets degraded or gets in a worse state than the other. So you might need to change some bits, or you might discover some new technology that you want to upgrade in some parts of your plant. So you might need to do that as well. So that how you manage that change is also very important. And then maybe after 20 to 25 years, you decide, actually, I don't need this plant anymore, or everything is a bit too old for for us to actually make good use of it, and it might not even be safe anymore to use. And that's where we go into the stage decommissioning, and we want to take out any contaminants in that state. So this is the sort of life cycle of an engineering project or an engineering plant, and safety engineers are important in each and every aspect of this life cycle I've talked about. So some of the principles that we look through as safety engineers is to understand how can we minimize any hazards. So when we look at hazards, those are things that could go wrong. What could go wrong with our plant? And if we realize that there are things that could go wrong, we want to try and see how to minimize it. We also want to look at how we can substitute it, and that's basically us taking out whatever is causing the hazard and putting in something that would not cause the hazard, for example. We might also look at a way to moderate that hazard. So if we can reduce the effects of the hazard, or if we can also simplify our project or our plant or our equipment to make sure that, the less complicated it is, the less likely we can have a hazard or we can have an accident happening. So these are all the things that, safety engineers generally get up to. So you get to see the different parts of, the construction and operation of a plant. And you also get to work with the different engineers, so on electrical aspects, process aspects, mechanical aspects as well. So it's understanding how all the different aspects work together as a system. And it's a very interesting area of engineering to get into. Now, my advice for you would generally be to stay curious, because there's lots of things happening in the engineering sector, and engineers solve challenges in different sectors, so whether it's energy or it's in buildings or in healthcare. So definitely stay curious. And now what we can see more and more is that there's the need for us to understand different industries. So as someone working in the energy industry, you might also need to, build an energy engineering solution for a healthcare plant. And so you have to understand both of those disciplines as well. Now, you're all unique. And so making sure that you embrace your uniqueness is very important to be a successful person within the engineering industry. And bringing that uniqueness into the engineering industry is definitely what we need, because there are quite a few challenges that we need to solve. And, we can't just have the same people solving these challenges. It's also important to stay flexible and be able to adapt to many situations. Now, definitely there'll be, solutions that need to be developed quickly. And, this is something that, if you're flexible and you're adaptable, you can work with those challenges within the industry as well. Now, also, form a community of people that are also interested in, being successful within the STEM industry and being an engineer as well, and find mentors that are already doing engineering, and ask questions, get to understand, learn from their experiences. And I think that that would be very important. And just remember, anybody can be an engineer. I'm happy I got into engineering because it has given me the opportunity to work on different projects that help bring value to people. And I think that that's really important. And it's been a great way to also meet amazing people and win some awards as well. So I'll definitely say, if you're thinking of being an engineer, yeah, just go in, try it, stay curious, and find people that are also have already succeeded in that space. And yeah, let's see what you get up to. Thank you very much.
As a safety engineer, you're across such a broad range of everything, basically, and you're dealing with engineering from all different angles, which is probably unlike most engineering jobs where you're sort of confined to one role and you're dealing with one specific thing. Is that what you think is, I guess, the most interesting side of being within the safety side of engineering? Is that what's most compelling to you?
Yes, definitely. For me, it's quite interesting because I have a background in chemical engineering, but for me, it's, I could also be having to understand a bit about electrical engineering, or, having to understand civil engineering as well. And that's, very interesting because you're always learning, and, you don't feel like you're just doing the same thing over and over again. No day is literally the same as the next. So, yeah.
How do you do that? How do you have an idea of, across all of those different specialties when your foundation is in chemical engineering? Is it because the fundamentals of engineering all lie in the same thing? I mean, I hear it a lot, that curiosity. Is that just the most fundamental thing?
Yes, I think it's curiosity and being able to work in a team. Obviously, you're not tending to work alone. So, being able to communicate and work with other people. So you don't need to learn. Obviously, everyone is a specialist within what they're doing. So I can't say I'm doing an electrical engineer's job, but I have to understand a bit about, the electrical engineer and what the electrical engineer has created or is designing, to understand how that ties into the safety of the system. So, yeah, just being able to communicate and understand that and learn as well within it, I think is very interesting and challenging as well.
And you mentioned a lot about the global challenges, the environment. How is that changing people's ideas of engineering? Is it making people more interested in the field?
I would say definitely we should get interested in the field, and that should be one thing, because now we can sort of touch things, and we can, like, some of these things are affecting us, right? So, for example, climate change is something that is definitely affecting us. Sometimes we think, oh, it's too hot the summer in the UK now, and that is an effect of climate change. And engineers are working to solve that. So, because it's more real to us now, I believe that should be a bigger driving force for people to say, actually, let's get into engineering, let's try and solve these issues. And there's so many things that one can work on, and engineers are definitely best placed to provide those solutions.
I've got loads of questions for you, so I could keep on going for ages, but I do want to hand it over to the audience. Please put your questions in the chat if you have anything that you would like to ask Titi. We've actually just had a question in from Nikat, who says, how do you come up with your inventions and designs?
That's a good question. I think we have to sort of, it's a collaborative effort, definitely. So it's not one person sort of coming up with it, and it's about getting people together to understand what do we want to solve, and what are the current challenges in what we have as a solution right now, and then taking it from there. So that's sort of how you come up with designs and innovative solutions.
And I'm going to mix Emma and another question together. So thank you both. Why did you want to be an engineer, and what's the best thing about it, in your opinion?
So for me, I really liked maths and science, though they just sort of made sense to me. And so that's how my engineering journey kind of started. So when I wanted to be to choose my course of study in university, I spoke basically. My dad sort of said, you like math and you like science, so why not just try, to study engineering? And being able to speak to people around me on what I could do as an engineer sounded quite nice. So I thought, okay, I'll go along with it, and that's how I've ended up here. Yeah.
Another question, what's the coolest project you've ever been part of?
That's an interesting one. I think I can't choose one exactly, but I think for me, one of the ones I connect with the most was working on the Elizabeth line, because being like, it's a massive project, lots of engineers on there, but being able to do a bit of that, to do some work on that was really cool, because now I can go on it and be like, oh yes, I was part of this. And when it does, I'm using, it's basically me knowing that I was a part of such a project. And even what I'm working on currently, it's really amazing as well, in terms of um, producing hydrogen at high pressures, which we don't have much of that happening right now. And it would be really good for us, because that output would really help, industries such as the chemicals industry or the shipping industry as well. And so, it's something that would be very beneficial and provide value to those sectors.
There's a bit of a combination of questions here I want to ask as well, because it was something that the idea fascinated me too. I was thinking, do you have to sort of mock up the hazards and sort of practice them out? One question here is, what sort of hazards do you come across on day to day? And the other question here is, how long does it take to design, test, and create new inventions? So yeah, is there a process that goes? Do you have to sort of like think what could go wrong, and then
Yeah.
sort of I don't know, make a demonstration of it?
No, so generally you don't have to, because you can learn from previous experiences or previous projects as well. But the good thing as well about safety engineering is that there's some, systematic or techniques that you can use to go through things like this. So you can try to understand, okay, what could go wrong in terms of, if we don't have, if we have higher temperature than usual, or if we had higher pressure than usual, that sort of thing. And then we sort of work through that and see, what could go wrong in within our design. So yeah, it's a combination of, and again, it's another teamwork, because we sort of all sit down together and think about these things. So it's an opportunity for us to work together as a team. And projects do take long, it can take years. So depending on how big the project is and what the scope of it. Yeah.
Loads of questions still to get through. What's your favorite thing about being a female in engineering? And do you have a community of women that support each other?
Yes, definitely. I've got, people I've met along the way that have, positively impacted me. Definitely like to keep in touch and, learn together, grow together. I think that's really important. Being a female in engineering it has its challenges, but it's also a way to sort of work and show that, as an engineer, an engineer doesn't have to look a certain way. As long as you're interested and you learn the skills that are necessary to work as an engineer, you can be an engineer.
What job are you working on at the moment? Can you tell us? Is that something you can share with us?
Yes. So we're working on producing working on electrolyser technology that can produce hydrogen at high pressures when you pass electric current through water. So we're working on that technology. So yeah, it's quite interesting.
And have you got a lot of people asking this? Have you got one specific inspiration? You spoke about the network of women, but one specific person who's really inspired you along the way?
Quite a few people, I'd say. My family, they are constantly inspiring me, because they're, supporting and, different people sort of in different ways doing their own bit within their careers and their lives as well. But, I've learned a lot from everyone in my family. So my parents and my sisters and my brother as well. I'll definitely say, yeah, I draw inspiration from quite a few people and quite a few as you mentioned engineers as well within the industry have been very inspiring to me.
A lot of people are asking what age you started, and a lot asking, is it hard? Is it hard being an engineer? Someone said, can you rate it out of 10?
That's a good one. I'll definitely say it's challenging. It's not a walk in the park. But I think when you tend to see the results of it and the impact of what you're doing, that definitely gives me inspiration or gives me, fulfillment. So I'll definitely say, yeah, that helps. Yeah.
This one's short and sweet. Do you ever get hurt doing what you do?
I try not to. I think if I'm, I try to basically, as a safety engineer, I should be making sure that everyone doesn't get hurt. So I haven't actually gotten hurt before. So that's good. Thank God.
That's good. That's good to know. Because the next person asks whether it was dangerous working on the Elizabeth line, and I guess that's why you were there, right? To make sure it
Yes.
wasn't.
Yes, exactly.
And someone asked if something breaks, can you use the same materials again?
That's a good question. I definitely think you can do. So one thing we always look at is within some conditions. So I've done a bit of reliability engineering as well, which is where we look at things like this, like when failures happen, you do what is called a root cause analysis, where you can basically go through and say, okay, what then went wrong, and then you can use that learning, what you learned from that analysis, to make sure that you don't use it in that particular condition anymore, or maybe you have to, inspect it more often to be sure to catch it before it breaks, or maybe you just need to use another material, as you say. So yeah, there are different solutions to that challenge.
Thank you so much for all your questions. They're still coming in, so I'm going to try and get through as many as I can before we have to say goodbye to Titi. So next question for you. What characteristics of effective learning do you use the most? I guess people are looking for a little bit of some takeaway advice.
That's a good question. I think effective learning for me is being able to apply whatever I've learned. And so once I'm able to apply it to what maybe I've experienced before or what I'm doing in my work, I then try to make sure that I can, that for me, that's how I learn most effectively. And also, I would also say one other thing is, after what I'm trying to do now is, after a project, just going back and thinking, okay, what did I learn from this experience? What will I change? And it's a very important principle even within safety engineering, because the most you don't want to make a mistake twice, because then that doesn't make sense at all. So yeah.
I'm going to combine another two questions here. First being, what was the first project you worked on? And then the next being, how many inventions have you made, or how many have you worked on in your career?
I can't count the number of projects I've worked on in my career.
A lot then.
Yeah, quite a few. But I would say the first project I worked on, that was actually for an internship that I worked on while in school, and that was an interesting one actually. It was for an oil and gas plant, and we had some sort of so within the pipes we saw that some solids were forming within the pipes, and what we were trying to understand, what was happening that was making, basically we should have had liquid and gas flowing through, and instead we had some solids forming, because when they reduce in temperature, or when they experience a reduction in temperature and pressure, they change phase. So that was actually a very interesting one, because it was about understanding what is actually going on within this piping as it goes. So yeah.
There's a lot of questions about your childhood. What were you like as a child? How early did you decide you wanted to be an engineer? And were your parents engineers? So a bit of a mixture of questions together.
All right.
But what were you like as a kid,
Yeah.
I guess?
So I'd say I loved reading books. I still love reading books. Just that, now I don't read as many as I used to. But I was just a very curious child. And I think also wanting to understand things. I think generally I'm not the typical engineer that well, I won't say typical, but quite a few engineers I know used to break things apart when they were younger, but I didn't do that, but I was just really curious about things. And my parents are not engineers, but I have people in my family that were engineers, but they also just, encourage that atmosphere or that environment for me to ask questions and always learn learn things that I was curious about. Yeah.
So would you say, because this is another question, that the personality and the skills, do you think that kind of sums it up? What if you were to sort of list off the personalities and skills you need to be any type of engineer? One person asks why there are so many types of engineers, but what would you say as a bit of advice to the people listening?
So I don't think there's any particular personality trait as such. Like, we have different types of people, but I'd say definitely being somebody that likes a good challenge, or being somebody that wants to learn a bit more about how things work, and how things could work, are some key bits of it. But as you say, there's so many types of engineers that if you are the kind of person that also just wants to research about things, there's the place for you in engineering as well. Or if you're somebody that's like more wanting to touch things, work with your hands, there's a place for you as well within engineering. Yeah.
A lot of people saying, was it a good idea to become an engineer? / what is the worst part of being an engineer? Is there a worst part?
That's a good question. The worst part, I'll definitely say, I mean, it's not easy. It's not an easy job, to be honest, because there's a lot of responsibility on you, because people are using your solution. So whether it is that you're building something that people would use in hospitals, or that the public would use, or there's definitely lots of responsibility. So it's a lot of hard work, constant learning as well. So yeah, I mean, those of course can be enjoyable, but then also it's not always enjoyable having to work on these things. Yeah.
Time for a quick fire. One last question. Do you think F1 will use hydrogen powered cars soon? Formula One racing.
I don't know. We'll have to find out. We'll have to wait and find out.
Maybe
Yeah.
time for one more. Do you work on dirty projects?
Dirty project. I mean, yeah, definitely. I mean, there's some bits of engineering. Not every part of engineering is, what's called. There's the bits that you can do in an office, but there's also things that if you did want to get your hands dirty, as they say, you could get involved in as well. So yeah.
Wonderful. Well, that is all the questions we got time for today. So thank you everyone for joining us and for sharing your amazing questions. They were fantastic. And a special thanks to Titi Oliyide for inspiring all the engineers in the making out there. Now it is your turn to come up with your own engineering ideas. So remember to send them to us once you're finished so we can get your certificates sent out. And hopefully we'll see you in person at our public exhibitions at the end of the school year. The deadline is March the 22nd. So once you've got your ideas designed in class, get them sent over to us. Thank you, everyone. And a special thanks again to Titi. And remember, if you were an engineer, what would you do?